Hello, welcome to 2HTV. In today's tutorial, we are actually going to look at a past question. That's end of semester acid, base and salt 2023. We are going to look at the calculation aspect. So as the question is being projected, we read together. Now let's read. A buffer solution was prepared by mixing equal molar amounts of ammonia and ammonium chloride. If the concentration of ammonia was 0.10 molar and Kb of ammonia is 1.8 times 10 exponent negative 5, determine the following. A. The pH of ammonia solution used. B. The pH of the buffer solution prepared. C. The change in pH if 0.02 moles of HCl in aqueous is introduced into 1 dm cube of the prepared buffer solution. D. The change in pH if 0.01 moles of sodium hydroxide in aqueous is introduced into 1 dm cube of the prepared buffer solution. Salt. Concentration of the salt over concentration of the base. So this is the Henderson-Hasselbalch equation. This is the equation that is used for buffer calculation. Now the salt here can also be referred to as the acid component of the buffer. Okay, so you know that a buffer solution is a solution that is able to resist change upon the addition of small amounts of what, either acid or base. So this is a basic buffer and it occurred between ammonia and what, ammonium chloride. So it's a reversible reaction. So this is the reaction for the buffer. Now they say that we have to, so let's write down the parameters. Let's write out what is being given. So in the equation they gave us the concentration of ammonium to be 0.10 molar. So concentration of NH3 is equal to 0.10 mole, and they said that the ammonia and the ammonium chloride have equal molar, so they have equal concentration, meaning that the concentration of ammonium chloride is also what, 0.10 molar. Take note. So they've given the Kb value to be, so our Kb value is 1.8 times 10 exponent negative 5. So we know the concentration of the ammonia, the ammonium chloride. We know the Kb value, so we can quickly input that into the Henderson-Hasselbalch equation to get the pH of the base. Now note that pKb is equal to negative log of Kb. So we first find the value. So pKb will be equal to negative log of 1.8 times 10 negative 5. So when we quickly input that, we will get 4.745. So we are getting the pKb value to be 4.745. So now we can quickly insert our values. So our pOH is equal to 4.745 plus log of 0.10 divided by 0.10. So we have 4.745 plus this one will give us 1, so log 1. And log 1 is quickly inserting that log 1 is 0. So 4.745 plus 0, that is giving us 4.745, right? So that is the POH. So our POH is 4.745. So we are done with our A part. Let's quickly look at the B part of the equation, which says that we are to find the pH of the buffer solution prepared. And we know that pH and POH sum up to give us 14. So POH plus pH should be giving us 14. Now we know POH, right? So we can find our pH, which is equal to 14 minus what? POH, right? So 14 minus the answer that we found, and it was 4.745. So when you subtract that, you will get 9.255. Using your calculator, you get 9.255. So this is your pH. So our pH is 9.255. So the B part of the equation is being answered. Quickly to the C part of the equation, right? So the C part of the equation is also saying that we should calculate the change. So what is the change in pH if 0. So change in pH if 0.02 moles of what HCl is being added. So now that we are adding 0.02 moles of HCl to the buffer solution, it is going to increase the acidic component, that is the salt content, right? So let's see how the equation looks. So you write your general equation. POH is equal to pKb plus log of the salt concentration of the salt. The salt is the same as the acid because it was an acidic salt. Then the base, so it will increase the acidic component by same amount, so plus 0.02, then minus 0.02. So you just quickly insert your values and just do this. So our POH is equal to, we know our pKb. So our pKb was 4.745 plus log of the salt, so 0.10 plus 0.02 divided by 0.10 minus 0.02, right? So this is what you are going to get. So when you quickly add this and find the log of it, you will get 0.176. So 4.745 plus 0.176. When you set all this into your calculator, this is what you are going to get. So when you sum this up, you will get 4.92, right? So the POH is what? 4.92, but we are asked to find the pH. We know that pH is equal to 14 minus the POH, which is 4.92. So when you do this calculation, you will get 9.078. 9.078. So this is how you go about it to find your pH when an acid content is being added. So when a basic content is added, it will increase the base content by same amount and decrease the acidic or the salt content by same amount. So looking at the D part of the equation, which says that we should find a pH when 0.01 NOH is being added. So since a base is being added, it will increase the base content by same amount and decrease the acidic content by same amount. So our equation will be POH is equal to pKb plus log of our salt, concentration of the salt, over concentration of the base. So it will decrease the acidic component, which is the salt, 0.01, and increase it by same concentration, 0.01. So quickly inserting our values, our POH is equal to 4.745 plus log of 0.1 minus 0.01 dividing 0.1 plus 0.01. So when you quickly use your calculator to punch all this, you will get let's do that, 4.745 plus log of all this using our calculator very fast, we will get minus 0.087 minus 0.087. So when we finally add this, we'll get our POH to be equal to 4.658. 4.658. So we have to find pH. So our pH is equal to 14 minus POH, right? So pH now is equal to 14 minus 4.658. So when you punch that on your calculator, you will get pH to be 9.34. So 9.34. So you could see that the pH when sodium hydroxide was added, it has from our first part, it has what? Our real pH was 9.255, right? So when sodium hydroxide was added, it increased the pH little, just a little, and when HCl was added, it also decreased the pH just a little. So that's how buffer works. So take note that when an acid is added, it will increase the salt component and decrease the basic component. When a base is added, it will increase the base component and decrease the acid component by same amount. Thank you so much for your time. Please subscribe, share, and comment. Bye.